So we're talking about storage improvements in vSphere 5.1 to help with your desktop virtualization project. So some of the features we'll talk about are new to 5.1 and some are just improved for 5.1. And I haven't picked out all of the storage enhancements that are in 5.1. There is a lot. I've just tried to pick out the ones that are, I think at least, are useful for desktop virtualization. My name's Jim Moyle. You can find me on Twitter. I've actually spelt my own Twitter handle wrong now. So let's just change that. There we go. So you can find me on Twitter at Jim Moyle. And I've got a blog at jimmoyle.com, but I don't post there very often anymore. Twitter seems to have taken over. I work for a company called Atlantis Computing, who do software storage optimization for desktop virtualization. I'm also honoured to be a member of the CTP program. Why do we need storage enhancements in the hypervisor? Well, as we all know, desktop virtualization is pretty hard on storage, so if we can bring storage features or bring caches into the hypervisor layer, then that's a good thing. There are two main problems that we're trying to solve with a couple of these storage bits, and we'll describe the problems and then we'll go through the technologies and why they're important to these issues. First issue is the early bird problem. If you have shared storage, then as your first guy comes in the morning, he has got access to all of that shared storage. So if you've got 1,000 users and you provided 20,000 IOPS to those users, the first guy to come in the morning has got access to 20,000 IOPS. Woo! By the time the 1,000th concurrent user logs on and it's 3 o'clock in the afternoon, he's got access to 20 IOPS. Boo! So this change in user experience over the day is very bad, because users can get used to anything as long as it's consistent. So I've gone into customers where the user experience has been terrible, but it's always been terrible, and there are no more support tickets generated from the fact that performance is terrible, because everybody's used to it by now. If you have a very variable user experience, then users will complain. So the problem with having a centralized storage infrastructure is the early bird problem. Second problem is noisy neighbor.
Way too tiny for James. And there's no beer.
That's a good point, actually. I'm presenting a pub forum without a beer in my hand. That's terrible.
Sunday morning before 12.
So essentially, previously there's been very few quality of service and fair use or fair sharing features within the hypervisor for I/O. Hypervisors are actually built on fair sharing technology, fair sharing CPU cycles. So that's the original thought behind virtualization hypervisors, fair sharing of CPU cycles. And then as hypervisors grew up, you get fair sharing of RAM, so there's lots of features to do, make sure that everybody has a minimum, maximum enough RAM. I/O has been a problem though. I/O has been a problem because it's much more difficult to try and do quality of service and fair use on I/O. And as we've been talking about this last few days, I/O is very, very bursty, very peaky. And it means that if somebody peaks too high, they can steal the I/O from everybody else. So this slide is a UK government department. It is 1,000 concurrent physical XP desktops. And this is a measurement of the total I/O in that environment from all of those 1,000 physical XP desktops. This data was gathered using Centrix, and they kindly let me use it, so thanks to the guys at Centrix. And we can see here, we've no log on Storm, by the way, because this is a government department, so they've got flexible working, so they log on gradually between sort of 7 a.m. and 11 a.m. They all go home at the same time, no? This here is the lunchtime log on Storm. So what we can see is that we've got peaks of up to 48,000. Now if we take an average of this day, the average of 1,000 physical XP users from 7 a.m. to 7, this average is 6,000 IOPS. 6,000 IOPS divided by 1,000 users, 6 IOPS per user on average. Anybody seen? Anybody? Thanks for clapping my maths there. Yeah. Anybody seen average 6 IOPS for Windows XP and on websites? Yeah. I've seen that as well. Anybody see a problem with providing 6,000 IOPS to this? All right. So it actually means that in this area here, when all your users are logged in, you are guaranteeing a worse than physical desktop performance for 100% of your users. Do not size an average. But we can also see this early bird problem, right? Your guy here has got access to all of the I/O, and the people here are totally congested. So your early bird problem. This is a single Windows 7 VM. It's on Atlantis ILIO, so there's really no upper limit to the IOPS, right? So it's allowing it to burst as much as possible. And this is just a script that's opening a whole load of applications. And we can see as we open all the applications, we can see the peaks. Windows is doing a very good job here. It's doing exactly what it's meant to be doing. And it's taking the resources that are available to it to provide the best possible user experience. Excellent. That's exactly what it should be doing, right? But if you give it loads of resources, it will take it. So opening up Excel here, right, peaking at 4,000 outs there. So it means that if Excel takes 4,000 reads and 4,000 writes just to get itself open, then it's not being frivolous with these reads and writes. It needs to do the reads and it needs to do the writes. If you provide 4,000 IOPS, it will open in a couple of seconds. If you provide 100 IOPS, it will open in however many that works out. So Windows will burst. Now, if you do something really stupid, so if your help desk guy gets a bit frustrated with the user and says, you know what, I bet this will be fixed if you just run a full AV scan, and then they can go away and so they'll call back in an hour's time and they'll get somebody else, right? A full AV scan will steal almost all of the I/O available from a SAN, and your other 999 people will have a very, very degraded experience. So this is your noisy neighbor problem, and it's caused by the ability of Windows to peak. So the hypervisor is middleware, right? So it's middleware between your storage and your OS. So it's providing the sort of control level. And because it's there, it's sitting in the middle, it has the opportunity to do some cool things. It has the opportunity to help with some of these problems that we're talking about. And you tend to find at the moment that you're getting storage features going into the hypervisor. Now, sometimes these can be from the storage vendors, but mostly it's from the hypervisor vendors themselves. just before we go on, I want to just thank this bloke, Cormac Hogan, who is the VMware technical marketing guy for virtualization and storage. It seems that if you talk about virtualization and storage, you need to have a ponytail. It's just the way.
Yeah,
he's been a great help to me putting this set of decks together, and he's a great guy. If you want to know more about VMware and virtualization and storage, follow him. Some really good stuff here. So his Twitter is at VMware Storage, and his blog is Cormac Hogan. If you'd like to tweet that I'm giving him props right now, then that's absolutely fine, because he'll like that. So, one of the best things coming out is the VMFS 5. So, I'll not talk about all the features that VMS 5 gives you, but the ability to have the unified block size and change the so it used to be up to 8 meg. So you used to produce bigger VMDKs. You used to have an 8 meg block size, but now it's 1 meg all the way. So it's very easy to upgrade to VMS 5. Bam, it's right there. The trouble is that if you do an upgrade, you don't get all the features.
And it doesn't change the unified block size.
It doesn't change the unified block size, absolutely. It also continues to use 64K subblocks instead of 8K subblocks, and it will keep the MBR partition if it's below a 2 terabyte file size. I would advise, if you're using VMS 5, not to do an upgrade. I would do side by side and do a storage vMotion into it. So, starting sector is different. Again, this doesn't change for upgraded. Yeah, the MBR to GBT. So essentially, definitely do a storage vMotion onto a new bit if you possibly can do. So we're going to talk a little bit about Vue in this session. I know there's who uses Vue? 2 or 3, 4 people. I pretend I'm not a CTP. I like Vue. As a broker, I think it's fairly equivalent to Zen Desktop. Don't see any customers have problems to use it. So it's if it seems, especially for licensing, if you can get it for free, use it, right? But Vue has this concept of Vue storage tiering, which is when you create a pool, you can either have the replica centrally or you can have the replica distributed across the storage. If you were in the session just before, PVS holds things centrally, MCS has distributed. So it's kind of the same difference between the two. They call it Vue storage tiering, but yeah, that's all it does. You can show where you're going to put your replica. And I do like the ability to do this because there are situations for both where both is best. One of the things that I'd like Cedric to do with MCS is the ability to do this, and then we could, almost completely kick PVS off the face of the planet. So VMS 5.5 sharing limits in vSphere 5.1. So in vSphere 5, you got this with NFS, but they didn't make much of a song and dance about it because they hadn't got it in VMS 5 yet. Previously, the maximum number of hosts which could share a file on VMFS was 8. This is why you had an 8 cluster limit on Vue, because when you have your replica shared centrally, you can only have 8 hosts access to that shared replica. And so your cluster size was limited to 8 because of the view storage tiering. You now get 32. So you got 32 with NFS and 5, now you get 32 with VMS 5. So for scalability, much better. Let's talk a bit about VAI. Now VAI has been around a while. And I think VAI, so you noticed that hypervisor is middleware, and sometimes you get storage features by the storage features put in by the hypervisor manufacturers, and sometimes you get storage features moved up, or even hypervisor features moved down into the SAN from the SAN vendors, because snapshotting and that sort of stuff you can access directly through VAI. Now VAI requires a module written by the storage vendors. There's a new ability to search on the VMware HCL. You can search for SANs which have VAI on them. There is, I think, 600 different bits of storage that you can use VAI with, which is considerably less than if you just search for storage, right? And I don't know why this is a problem, because I like VAI when it works. Yeah, it's great. If you're offloading storage-specific virtualization functions back to the SAN, that's great. But for some reason, there hasn't been a big move from the storage vendors to write the modules to put into vSphere. Now, whether it's time on their hands, or I don't know why, but in my opinion, there isn't half as much storage vendors that take advantage of VAI as there should be. vSphere 5.1 gives you a little bit more advantage for VAI. And hopefully there'll be more SANs with it, but it's been around for a while, right? And I don't know why the uptake of it isn't as good as it should be. So you get better thin provisioning, which is all very nice. I'm not going to go through read out the whole slide. But dead space reclamation is kind of important. So when you do a storage vMotion, it doesn't. It leaves the blocks around, and dead space reclamation means that you can delete these blocks from the SAN. Now, unfortunately, when they released this feature in vSphere 5, they had to immediately withdraw it because there was a bug in it. It's back again in 5.1, but only via the vmkf tools command. So if you're doing lots of storage vMotions and you find out that you're running out of space and you don't know why, it's probably because of the dead space reclamation hasn't been done, and you can run the command to bring it back. So that's back again in 5.1, and hopefully we'll be back again in the GUI in future versions. So VCAI again was around in 5, N5.1. Now this is still tech preview in View 5.2. I don't know why it's still tech preview. Again, it takes the storage vendors to write some software to put in to enable this. So maybe they're not interested in. NetApp isn't that interested in desktop virtualization. Maybe it's a hard job to do. I don't know. But essentially, what it's talking about is trying to get composer integration with the SAN. So instead of your composer doing all the link clones and your hypervisor doing all the link clones, it will offload the job to the storage.
But it doesn't make sense that they put a technology preview in the public version.
They do that all the time, though.
Yeah. It doesn't make sense that they put it in the public version. It should be a better version for the vendors.
I agree.
It has to do with certifying the plugins.
Yeah, is it? I don't know.
Certifying the plugins, yeah. That's why it's a technology preview.
So it was a technology preview in View 5.1 and 5.2, and there's no published date of when it's going to be in. I think it's a nice feature, but it's just seeming to take ages to come to fruition. It's exactly the same with a couple of other features as well. So as yet, tech preview, don't use it. Well, or use it advisedly rather. Storage I/O control. I really like storage I/O control. So this helps solve your noisy neighbor problem. Okay. So it provides cluster-wide storage analysis, so not just per host. It recognises that if you're accessing the same LUN, or even different LUNs with the same disks, importantly, it will essentially go out and test those LUNs, and it will get a latency score for them, and it will try and make sure that you haven't got somebody stealing all of your I/O. So if you've got a very I/O hungry app, it can't go and steal. And it does this by shares, okay? It does it by latency analysis on the storage underneath and shares. In 5.0, this latency analysis was pinned to 30 milliseconds. And as such, it was a fairly blunt instrument. So if you had SSDs or storage, or tier 1 storage, it couldn't tell the difference between them, and it just put 30 milliseconds latency. If you have SSD-based storage, and you're running up against 30 milliseconds latency, there's something very wrong. Yeah, it should be much further down. Now in 5.1, it means that the latency analysis is done algorithmically, and it takes much better account of SSDs and tier 1 storage. So if we have a look here, it takes, so you can see the limit of IOPS on it. So it takes this mechanism to actually limit the amount of I/O that a VM can demand if it senses that the latency is going too far up. It's an interesting little trick, actually, if you're doing VDI and somebody says that 10 IOPS is enough or 20 IOPS is enough, give them a VM that's limited to 10 IOPS. It's actually, the minimum is 16 now, actually, but yeah, wait until it's booted. So I'd actually never give them 16, because it will be, you can't even click on anything. 100 is horrendous enough to use for that kind of demo. So really important is across the cluster. So it means that you can put shares across each VM, and then it will share that I/O appropriately across your cluster. So if you implement this for VDI, it means that you can stop people stealing everybody else's I/O. You can put a limit on it. Interestingly, I've had people suggest that before the storage I/O control came in properly, that they would do this limit to prevent the early bird problem as well. And instead of making it good in the morning and shit in the afternoon, they just make it shit. Yeah. You need to get a consistent user experience. So it used to be that when you turned on storage I/O control, everything started there, but it has to gather the statistics about the storage before it can work properly. So storage I/O control is now on in stats only mode, so collecting the latencies and collecting all the stuff, so that if you do decide to turn it on, it will work straight away instead of having to collect all the stats previously. Again, I think that's a really good idea. And this is the automatic threshold computation. So like I said, it used to be 30 milliseconds, now algorithmically determined. Again, much better in 5.1. Storage I/O control should not be used for tiered storage, because essentially you're doing the same sort of thing in both the hypervisor and the SAN. So as VMware tests the SAN to get the performance and latency counters, if the SAN then tiers that bit of storage somewhere else, your counters and your latency stuff is all wrong. So either use tiered storage and allow the storage tier to try and take account of everything, or use storage I/O control. Do not use both simultaneously, otherwise you'll get yourself in a right mess. So this is all about the automatic threshold detection. So you can still manually set it, right? So it means that you can actually take over the I/O control if you don't agree with it, or if you're finding you've got problems with it. Storage DRS, so introduced in vSphere 5, improved in 5.1. So storage DRS will take all these stats and will select the best data store for your VM. This is actually really important for View when you're doing recomposes, because the recompose takes account of the CPU and the memory, but not the storage. So you can actually end up with your View environment really unbalanced because it doesn't take account of storage. Now, I like that smart placement, absolutely. What I don't like is the moving about the stuff while they're running. So, I mean, is DRS of any kind useful for VDI? I would say no, to be honest with you, because a interactive user workload like desktop virtualization is so bursty that by the time the demand's arrived, it's gone by the time you move stuff around. You don't get stuff that has high demand for a significant amount of time and then lowers it off. What you have is like boom. So,
well, it kind of depends on your architecture. If you have out of your 1,000 users, 50 of them that are high workload people, it would make sense to balance them out for different data stores. Not only for the I/O, but also for the bandwidth optimization, multipathing and multi.
So I would say yes for placement, but not for moving around.
You don't know placement when they just start working.
So if you have, that is the only possible. If you have persistent users and you have big differences in demand between your persistent groups of users, then possibly it may be useful. But there is VMware.
You should know that they were power users already, because
you should do. You should do. But then again, that's kind of difficult to tell, because what's a power user and what's a power application?
It's not up to you in your architecture. If you use new methodologies and automation in your hardware and hypervisors, you as a person should not be the one that decides who's a power user or not. Let the workload decide who is a power user, not you. Because it's not because you did an assessment and you looked at power users that doesn't change. People can become a power user.
it can be done dynamic.
Yeah, exactly. So if your environment is dynamic, let the hardware and hypervisor decide whether or not you are a power user.
So you know, when you got normal DRS, you got your conservative to aggressive slider. So that all depends on percentage differences between workloads, but it takes it over a 5-minute period. And that means that I think a 5-minute period for desktop virtualization is too long to analyze a workload. So yeah, for persistent, so developers, so somebody becomes a developer and they're doing loads of compiles, or somebody's doing media, then perhaps DRS will be useful for the difference. If you've got them all in the same pool, then yes, or in the same cluster, then yes. But in general, I would say don't use DRS for VDI, but bear it in mind as a fallback.
Is that also the best practice of VMware?
Now that's a good question. So it depends on which VMware document you look at. So you will find documentation.
Talking about storage DRS right here.
Well, I'm talking about DRS of any kind.
Okay. Because storage DRS is kind of different.
Yeah, of course.
You have storage DRS and you have tiering. Don't use both. It's the same as what you said previously.
Yes.
Don't use storage DRS on top of it.
On top of tiering, absolutely. But just widening the discussion to DRS in general. You will find documentation from VMware to say, yes, DRS is best practice for View. You will also find documentation from VMware to say it's not. I actually spoke to...
It depends.
It depends.
That in the articles.
If you use persistent desktops and have HA enabled for the high availability persistent desktops, they need DRS to rebalance them after a host. Because HA starts
Now, So if you're using DRS with HA, I'm trying to keep away from Ilio because it's more a general thing here. Okay, there is a possibility for defragmentation, and I don't like the defragmentation because defragmentation is not guaranteed. It's because DRS will not break affinity, anti-affinity, or reservation rules. So that relying on DRS to move things around in certain virtualization or certain desktop virtualization scenarios isn't a good idea. Also, you've got because Windows 7 VMs are small and you have a maximum simultaneous number of vMotions, then you could take multiple rounds of DRS. So the fact that defragmentation is not guaranteed and multiple rounds of DRS take time, then yeah, I'm not sure, but again, it depends. So data store correlation detectors means that data stores are backed by the same physical spindles. So this is whether it can tell. So it should be able to tell when you've got two separate LUNs, but they're backed by the same spindles now, which is much better than before. So essentially, if you see latency increases on both data stores simultaneously, yeah, vSphere will say, right, well, those two data stores are probably backed by the exact same bit of storage, and then we'll treat them appropriately when it comes to storage DRS.
What if that treats like a controller error?
Sorry?
What if you see an increase in latency across multiple data stores isn't actually down to the underlying spindles, but say an issue on the controller?
I don't know, to be honest with you.
So could it accidentally correlate to the ETA?
It sounds plausible, but I don't know. I suppose that you would get a temporary effect if that happened, but then it would start to even out after time. So, because this is a continuous process that it analyze it, then so storage vMotion enhancements.
So back to your slide, I had a question. What do you mean with the third point? This was previously done by VASA. I didn't think VASA did anything except for telling this is a data store with an SSD and all that. What did VASA do here?
Well, VASA's like dead in the water, isn't it? So
for now, yeah.
Yeah.
I didn't know that it had anything to do with active work like data store correlation.
I don't know either, to be honest with you.
Okay.
Storage vMotion 5.1 means that you can simultaneously move VM decays rather than being sequential. So again, you're going to get a much quicker movement of VMs who've got multiple VM decays, multiple disks attached to the VM. 4 per host. Yeah. Hence the. Yeah.
The main change was that they used the Delta file and now they use a mirror driver to do the storage.
Yes, much more efficient because you're not doing continuous deltas. Yeah. And so when it starts to move, it then mirrors the I/O to both LUNs. Yeah. So for desktop virtualization, I like the addition of the smart stuff because it means that if you do have SSDs in your environment, vSphere will now be much more intelligent about monitoring and using those drives. So I'm not going to go into these, but wear out and relocated sector is really important for the information that Smart brings back into the hypervisor. You can actually look into them with the CLI. This is my favorite one. Absolutely favorite. Space efficient sparse disks. Talk about delta inflation. Funnily enough, one of the use cases that VMware says for space efficient sparse disks is linked clone persistent. do not do link clone persistent. But at the same time, it means that you're cleaning up the inside of your VM. So if you have an advanced storage system for your VDI, whether it's SSD or really old, whatever, it means that your capacity is a big deal. And it means that you're bringing your capacity down from where your delta would, or depending on workload, but would expand to the size of your disk. When you've got space-efficient sparseness, it means it cleans this up, and that your delta will only expand to the size of your data, rather than the size of your disk. Right? So if you've got a 60 gig drive and a 20 gig data in it, it should limit it at 20 gig. Well, bring it back down to 20 gig anyway. So, excuse me. So, SE sparse disks are only available in View 5.2 sitting on ESX 5.1 if your hardware version is 9. So when you delete a file from within Windows, so this is what the blocks look to storage normally. This is what blocks look like to storage after you've deleted the file. It's exactly the same thing. And what SE sparse does is it will take those away after you've done file listing, or even file resize. So if you've got page file that's being resized all the time, so some people pin the page file in VDI, and some people allow Windows to manage it. I think the arguments for both of those approaches, but it's a big contributor towards your delta size inflation if you have a variable page file. So it's a new type of disk, but the ability to reclaim space means that you have to have the disk to start with, and then through VM tools, there's a wipe and a shrink activity that brings the space down. So this is not real time. It's important to note. I would like it to be real time, but there is a significant I/O overhead to doing this operation. So what it means is this has to be run in off hours. So wipe through VMware tools, scans unused file space, reorganizes the SE sparse disk to create a contiguous free space at the end of the disk, and then does a shrink command on the disk. So, as I say, View is the only VMware product that will use SE sparse disks at the moment. And only when you're using link clones as well. So you've got to have Composer there, you've got to have V5.2 there, you've got to have vSphere 5.1 there. And it will automatically do SE sparse. You can see that you have a blackout timer for it. So this is why there is a blackout timer, because as I say, it's a very, very I/O intensive job. And so you need to be able to do the blackout time so you get it outside of production hours. There is a tool that you can use if you don't have SE sparse disks, and this is sdelete. So sdelete is a sysinternal tool by Mark Rusinovich, which actually stands for secure delete. If you're trying to do the same job as SE sparse disk with sdelete, make sure you run it with a /z argument, because that will zero out your contiguous free space. Sdelete without any arguments will securely delete your hard drive.
Yeah.
There's also a /c which will put random data in every single block, and so you don't want to be doing that either. Like I say, only for View link close, and also you need hardware version 9. Won't work on version 8 or below. Having said that, it's only available for those set of circumstances. It's not quite true. You can use VMKF's tools to create an SE sparse disk. And if you cat the VMDK file, you can see you get SE sparse there. So so you can tell whether you've managed to create it, or you can tell whether a disk is SE sparse. Yeah, and you can see that you got the new Flex SE type. You can actually, so this only creates the disk, it doesn't enable you to do the wipe and the shrink. To do the wipe and the shrink, there is actually a trick by using URL, what they call it, URL frigging to do the wipe and the shrink as well. If you want to know about that, it's on the vGetO site. vFlash, I was hoping vFlash would be coming in. It's not. I was trying to get some information from VMware, some timelines for both vCAI and vFlash implementations. The answer to that was no chance, Jim. I'm not giving you any of that information, which is fair enough. You know, it's a software house. They're not going to let me announce to the world that they're going to have it by, June. So we're waiting for vFlash. Hopefully, it will come along soonish. So increasing file share limit on VMS5 from 8 to 32, much more scalable. Making view desktops much more space efficient using SE sparse disks, and the new enhancements, so storage DRS, storage IO control, and storage vMotion are all great features for desktop virtualization. And if you're doing desktop virtualization, you try and take advantage of all these features. And that's it. So thanks very much, guys.